Good morning, everybody. If we could start with some green checks, and I have the learning guide up from Unit 8. If you could let me know if you had any issues with any of the problems there. And just put the question number into chat from the section tangent ratio where we left off last day. And if nobody has any questions, we'll just continue on into sine and cosine today. And basically, once we've learned the three trig ratios, tangent, sine, and cosine, there isn't anything else. That's it. So we're almost done. The last section, Lesson 4 is just using the trig laws in like word problems and things like that. So yeah, it won't take long. We'll likely finish it on Monday. So that's kind of my hope at this point. Connor, Eric, are you with me? Eric is. Connor's not. All right. Does anybody have any questions from that learning guide? Anything they didn't get? Anything they wanted to see done? Going once, going twice. All right. On to lessons 2 and 3. So we've already done an activity similar to this, so we're not going to do it again. So for those of you who had submitted that first assignment we did on discovering trig, thank you. For those of you who haven't submitted it, please submit it. So we're going to just jump down to this page section, I should say, the primary trigonometric ratios. So we talked about the tangent ratio, and remember I said when we have these ratios, we need to establish what angle we're dealing with. And then every question, it's going to be a little bit different depending on what angle we're dealing with. And we could be dealing with the same triangle, and the opposite and adjacent sides can switch depending on what angle we're using as our reference angle. So for this question, or I guess this isn't really a question, but for these notes here, we're going to use everything from angle A, and we're going to label all of our sides from angle A. So the longest one is always going to be the hypotenuse. And then we have the adjacent and the opposite. So this is the only place you can kind of get caught up when doing these problems. Remember, if we have our reference angle, if we go straight across to the opposite side from the reference angle, and then the adjacent angle, or the adjacent side, I should say, is always going to form the angle we're dealing with. So if we're dealing with angle A, it's always going to form the angle with the hypotenuse. So we have our adjacent side down there at the bottom. So our reference angle is A. We look at our triangle. We measure all of our sides from angle A. The longest side is hypotenuse. We go straight across to the far side from A. That's our opposite. And then the adjacent side is the one that forms the angle with the hypotenuse. So in this case, down at the bottom. So the tangent of angle A is the ratio of the opposite side over the adjacent side. So we did some problems regarding the tangent ratio last class, and today we're going to look at the sine and cosine ratios, and they're the exact same process. Literally nothing changes except the two sides we're dealing with. So in a right angle triangle, there's three sides. We can have, opposite and adjacent. We could deal with the hypotenuse and the opposite, or we could deal with the hypotenuse and the adjacent. So the thing with trig is you're going to be given two sides and be asked to find the third, or you're going to be given a side and angle and asked to find another side. So you're always going to be given two pieces of information, and you can find the rest of the triangle from those two pieces of information. So if we wanted to find the sine ratio, so instead of using the tangent ratio, if we want to use the sine ratio, same process, except when we are dealing with the sine ratio, we're dealing with the opposite side. And instead of the opposite over the adjacent, we're going to go opposite side over the hypotenuse. So exact same process, except we're just dealing with different sides. And then the cosine ratio is the same thing again. Instead of having, if we're given in the initial question, two sides, and it happens to be the opposite and the hypotenuse, then we know we're going to use the sine ratio. If we're given two sides like the adjacent and the hypotenuse, then we know we're going to use the cosine ratio. Okay, so these are the three different trig ratios we learn in grade 10, and they are useful for finding missing sides or missing angles in right triangles. And it's really, really important to remember that the only time we can use these trig ratios is if we have right angle triangles. It's not such an issue in grade 10 because the only triangles you're going to deal with are right angle triangles, but in grade 11 you learn the cosine law and the sine law, and you start dealing with non-right angle triangles, and students start getting confused with the trig identities. So sine is going to be I'm going to just abbreviate everything here. Sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So those are the three different side combinations you can end up with. So we can come up with a handy little, I guess it's like an acronym, it's not a mnemonic, I don't think. And that is SOHCAHTOA. SOHCAHTOA. And right now that looks like a strange word that you've never heard before, and it's made up, and you're just like, Mr. Borden, you've lost your mind. But you'd be amazed how important it is and how long it sticks with you to remember the three trig identities. So with SOHCAHTOA, we have our three trig identities kind of hidden in there. When you know what sign, use, so this is the SO. And what SO means is sine of some angle is the opposite side divided by the hypotenuse. So that's the first part of our little acronym here. The middle part is CA, which means the cosine of some angle is the adjacent over the hypotenuse, because CAH gives cosine adjacent over hypotenuse. And lastly, but certainly not least, is TOA. I don't know what happened to TOA in our notes here, but we'll include it. The tangent is going to be TOA, which is the tangent of the angle is the opposite over the adjacent. SOHCAHTOA. I'll say it often. We'll use it. So we only have these three trig ratios to deal with. The only questions we can see would be one that asks us to find the missing side or find a missing angle, which kind of narrows things down. Generally speaking, trig is straightforward when everything's like, use the tan ratio, use the tan ratio, use the sine ratio. But sometimes we'll be given questions where we don't know what ratio to use. It'll just say, find the missing side. And you need to be able to figure out which angles you're dealing with and which sides you're dealing with, and be able to figure out which trig ratio, sine, cosine, or tangent, you need to use. So this example, determine the measure of angle G and angle H to the nearest tenth of a degree. We're given this right triangle. We don't know the measure of any of the angles, but we're asked to fill out all three angles. We know that K is a 90-degree angle. And we have two sides. We could use the Pythagorean theorem to find the third side, but that doesn't help us find the angle, so that's not going to get us anywhere. So what we need to do is figure out what angle we're dealing with, and then label our sides. So the first part of the question asks us to find angle G. So I find angle G in my triangle. I label it angle G. There we go. And angle G is now our reference angle. We're going to label all of our sides from our reference angle. So in this question, it might be a bit tricky labeling the hypotenuse because the triangle isn't like, you know, normally the right angle is in one of the bottom corners, but now it's in the top. But hopefully we can remember the hypotenuse is still going to be the longest side. So this is the hypotenuse down here, and I'll label that hype. Then I need to label my opposite and my adjacent. So if I am starting from angle G, if I go straight across my triangle, I have my opposite, and the side that forms the angle with my hypotenuse is the adjacent. So I've labeled my triangle, I have my reference angle, I'm doing okay. Now I need to figure out which trig function to use. I'm either going to use sine, cosine, or tangent, and how do I know which one to use? Well, the question doesn't tell me, so I can pick whatever one I want, but there's one problem. The opposite side here, I don't know the length of it. I know nothing about it. So if I have a trig function that uses the opposite side, I won't be able to solve it because I just don't know what that side length is. So the important thing here is to use the information you're given. What am I given? Well, I'm given that the adjacent side has a length of 6, and I'm given that the hypotenuse has a length of 14. So if I wanted to use the adjacent side and the hypotenuse, because those are the two that I'm given, which of my three trig functions am I going to use? Put it into chat. A 33% chance. The one with the adjacent and the hypotenuse is Eric's feeling brave. Cosine. Yes, Eric, thank you very much. So the cosine of an angle is equal to the adjacent side divided by the hypotenuse. All right. Now, I don't know the measure of angle G, but I want to find it. So I'm going to call it theta, that Greek letter. So I'm going to stay with cosine of theta is equal to the length of the adjacent side, which was given in the question as 6, divided by the length of the hypotenuse, which was given in the question as 14. Now, 6 divided by 14 is going to give me a decimal. .42857. We'll go 4286. All right, so I'm just going to pause here for a second. I found the cosine of that angle. And really all the cosine is just a ratio of two sides, the adjacent and the hypotenuse. Now I found the ratio of those sides, and it's 0.4286. The question asked me to determine the angle. So when I'm doing trig questions, I can be asked to find a side or an angle. Now in this question, it asks me to find the angle. In order to find the angle, we have to do the inverse cosine, cos negative 1, of 0.4286. Now, the idea at the very beginning when we first started this unit was we're looking at ratios of sides. It doesn't matter how big the triangle is. I could be talking about a triangle from Earth to the moon to some other planet, and I could be talking about this triangle right here on my page. It doesn't matter how long the sides are, it just matters the ratio of the sides. So it could be a ginormous triangle the size of the solar system, or it could be a tiny triangle like on the page in front of us. If the ratio of the sides, if we divide those sides and we get 0.4286, we can figure out what the angle is. Now, you can plug it into your calculator, inverse cosine of 0.4286. I'm just going to go into my cosine table here because I like using these. So I'm going to find 0.4286. Where are we right here? 0.4226, 42. So it's kind of somewhere between 64 and 65 degrees. 0.4286, yeah. So it's going to be 65 or 64 point something. So I can do it like that, or I can jump over to my calculator and I can go inverse or shift cosine, and it gives me that negative 1, 0.4286. So 64.6 degrees. So that's the measure of angle G, 64.6 degrees. Okay. The question also asks to find the measure of angle H. Now, there's a couple ways you can do this. You can say, okay, the three angles in a triangle have to add to 180 degrees. I can go 180 minus 64.6 minus 90, and whatever's left has to be that other angle. And that's fine. So let's do that. I'll maybe section this off. I'm going to go 180 minus 90 minus 64.6. And whatever's left is going to be the angle. So 25.4, of course. I could also use trig to find it. I could relabel my triangle. I could say this is my reference angle here. This is now my opposite over here. This is my adjacent over here. And I could redo the calculation like I just did. And that's probably what I'd normally do. Anybody have any questions on that first example there? Number 2, a water bomber is flying at an altitude of 5,000 feet. The plane's radar shows it is 8,000 feet from its target site. What is the angle of elevation of the plane measured from the target site to the nearest degree? The angle of elevation and angle of depression are two kind of vocab terms associated with math. Angle of elevation is looking up. Angle of depression is looking down. So let's draw a picture. Here is my plane. It's a great looking plane. Flying at an altitude of 5,000 feet. So from here to the ground is 5,000 feet. The plane's radar shows that it's 8,000 feet from the target site. Here's my target. And it is 8,000 feet from the target site. So I'm going to draw a right angle in this bottom corner to indicate that I have a right angle triangle. It says, what is the angle of elevation? So the angle of elevation is going up. I'll call it theta. It says measured from the target site. And I have a right angle triangle. So I need to label my sides. From my reference angle down in the corner here, we'll call it angle theta. If I were to go straight across here, that's going to give me my opposite side, the longest side of my hypotenuse, and then I have my adjacent down here, but I don't know it, and I don't need it, so I'm not going to use it. So now I need to figure out which trig function uses the opposite and the hypotenuse. So I think, okay, SOHCAHTOA. That tells me all three trig functions, sine, cosine, tangent. And I have the opposite and the hypotenuse. So I'm looking for the one that has the O and the H. So I see the O and the H together here. So that means I'm going to use the sine function. So the sine of some angle theta is going to be the length of the opposite side divided by the length of the hypotenuse. The length of the opposite side is 5,000. The length of the hypotenuse is 8,000. Now, instead of doing the division to get a decimal here, 5,000 divided by 8,000, I'm going to take the inverse sine of 5,000 over 8,000 on my calculator and see what it gives me. So this is just another way to do the problem. Up above, we calculated the ratio of sides, then we put it into our calculator. I'm just going to do it all in one step, and I'll show you how that looks on your calculator. So I'm going to go inverse sine because I want an angle. If I want an angle, I always have to do the inverse function. I'm going to open a bracket, 5,000 divided by 8,000. I'm going to close my bracket, and then it's going to give me my angle. So 38.68. We'll just call it 39 degrees. All right, so just some notes here to kind of help us along. Some steps, 2 5-step processes. And I know when we're first doing this, it seems like it's really long and drawn out. And that's because I'm taking my time and making it long and drawn out. But once you get into it, once you start, getting good at labeling your sides, these questions go very quickly. It's not like they take 5 minutes a question. Literally take you less than a minute. So to find a missing angle, the first half of our chart here, we want to first identify the angle you want to find. That's going to be our reference angle. We're going to label all of the sides on our triangle from that angle. Once we've figured out which 2 sides we have, that is the trig ratio we use. Set up your equation, solve for your angle. And one note I will put in here is we must use the inverse function. So we're going to have tangent -1, cos -1, sine -1 on our calculators if you're finding an angle. To find a missing length, these are the only two things that can happen in trig questions. To find a missing length, we have to figure out what angle we're given. We label the triangle from that angle, just like we did in the previous. Identify the trig ratio, set up your equation, solve. And for anything for a length, you're going to use tangent, cosine, sine. No inverses for missing sides. We only use the inverse when we're trying to identify the angle. All right. We'll do a couple more examples here and then give you guys some time to work. Determine the length of BC to the nearest centimeter. We're trying to find the length of this side from B to C. I'm going to go back up to our rules here that we put up above. We're trying to find a length. So the first thing we need to do is identify the angle we're given. And to me, it looks like the angle we're given is down in the left corner here, angle C. The second thing we do is label the triangle from that angle. So if I go across, that's going to give me the opposite. This is going to be my hypotenuse, and this is going to be my adjacent. I'm always going to have two sides that I either need or have. In this case, I have the opposite, but I don't need it. I'm not trying to find it, and it's not given, so it's of no use to me in this particular example. So what side do I have? Well, I have the hypotenuse, and I'm trying to find the adjacent. So that's the third step here. We identified the angle we were given. That was angle C down on the bottom. Labeled the triangle, did that. Identify the trig ratio. Adjacent to hypotenuse. I'm going to write out SOHCAHTOA and figure out adjacent hypotenuse. That is going to be that guy there. So that is the next step in our adventure. Number 4 says set up the equation. The cosine of some angle is equal to the length of the adjacent side over the length of the hypotenuse. I'm going to plug some numbers in, and then I'm going to solve for what I'm trying to find. So I know the angle. The angle is 50 degrees. That was given in the question. The adjacent side, I don't know what that is. I can call it X, you can call it Y, you can call it John, whatever you want. The length of the hypotenuse is 5.2. The idea here is I'm trying to find X, trying to find the missing side. So I want to get X by itself. So if I want to get X by itself, I'm currently dividing X by 5.2. If I want to get it by itself, I can do the opposite of dividing by 5.2, which would be multiplying by 5.2. If I do it to one side, I have to do it to the other side. 5.2 cancels on the right, gives me 1, and I end up with 5.2 times the cosine of 50 degrees is equal to X. Now, your calculator can likely accept that equation just like you've written it. So let's see if we can get it to work. 5.2 cos 50. I'm going to put in 5.2. I'm going to go multiplied by the cosine of 50 degrees. I'm going to hit enter, and I get 3.34. Does that make sense? Yeah, my hypotenuse was 5.2, so I know it has to be less than 5.2, and it looks like about 3, so that's likely. 3.34. And the question asks for the nearest centimeter. Which is kind of weird. We'll go 3 centimeters. Does anybody have any questions on that guy? Anything I did that dazzled you? You're like, wow, that was good, Mr. Borden. Didn't see that coming. No? No dazzling, just math happening. All right. Let's see if you guys can go through number 4. See if you can set it up. I'll give you a second to go through number 4, see if you can set it up properly, and figure out the length of DE. All right, first step would be to identify the angle we're dealing with. In this case, we're given 55 degrees, so we're going to start everything from there. We're going to label all of our sides from that 55. Longest side, the hypotenuse. If I go straight across, I have the opposite, and the angle is formed between the hypotenuse and the adjacent side. In this case, the adjacent I'm not trying to find, so I'm going to just ignore it. I go to my trusty SOHCAHTOA, and I figure out which trig identity I'm going to use. I have the opposite, I'm trying to find the hypotenuse. Opposite hypotenuse is going to be the sine. The sine of some angle is the length of the opposite side divided by the length of the hypotenuse. In this question, I'm given that the angle is 55 degrees. The length of the opposite side is 6.8, and the hypotenuse I don't know. I'm trying to find it, and it's called x. Now, last question we had the variable on the top. It was a little bit easier to solve. This one, it's on the bottom. Same process though. I have x on the bottom, I want to get it to the top. Right now I'm dividing by x. The opposite of dividing by x would be multiplying by x. That cancels it on that side, but if I multiply both sides by x, it brings it to the top on the other side. So now I have x times the sine of 55 degrees is equal to 6.8. I'm multiplying x by the sine of 55. The opposite of multiplying by sine 55 would be dividing by sine of 55. If I do it to one side, I have to do it to both sides. And I'm left with x is equal to 6.8 divided by the sine of 55 degrees. And you can likely plug that into your calculator just as it's written. So 6.8 divided by the sine of 55. And your calculator should just accept that. If it doesn't, you'll have to go sine 55, figure out what the decimal is, and then go 6.8 divided by that. So 8.3. .3 centimeters is the length of that side. Does that make sense? Yep, it has to be bigger than 6.8 because it's the hypotenuse, it's the longest side. So we'll go with that. Anyone have any questions there? Okay. The learning guide has a swaggle of questions. Let's go and get rid of a couple of them to speed this whole process up. So you did the first page, a number 11, and then you skipped number B on 11, or letter B. Then we have the sign ratio. So this is kind of where we looked at today. Sign ratio, all these questions are kind of broken down into sign ratio type questions. Let's get rid of number 5 on page 3. So don't worry about number 5. 6 and 7 should be quick. The cosine ratio. Those are all really fast. And then we'll lose number 5 on page 4 as well. Speed this up. Okay, so A, B, C, D. Let's do number 3. This is on page 5. Number 3, we'll do A. We'll get rid of B. We'll do C. And we'll get rid of D on the top of page 6. We'll get rid of number 8. This is on the very top of page 8. We'll get rid of 8. And we'll get rid of 9. And we will do 10. We'll get rid of 11. We'll do 12, and we'll get rid of 13, and 12, 14's there. All right, does anybody have any questions about that? Do I need to go through that again, or did everybody get all that? That's what I like to hear, Jenna. Nobody else has any anything to say? I'll give you guys a few minutes maybe to go through some of these problems. So finish the learning guide. Yeah, Eric, lesson number 4. This is what lesson 4, it says lesson 5, but it's only 4. Lesson number 4 is just solving triangles, and it's just word problems. So it's really, it looks a lot worse than it actually is. It's just more of the same. If you can do the couple word problems that are in the learning guide, you'll be fine. So yeah, I'm not going to just say finish it right today, but over the next couple days, if you could go through those problems. I won't do lesson 4, I don't think, on Monday. The problems in the learning guide are pretty straightforward in terms of word problems. So the only thing that I wouldn't have taught is how to look at the word problem. So if you look at like question number 10 on page 8, calculate the angle of elevation. And remember, angle of elevation is you have some surface. Angle of elevation would be the angle going up. So draw a picture. You have a person, you have a tree, and the Person whose eye is 1.8 meters above the ground. Looking at the top of the tree, which is 27.5 meters away. And it says the tree is 19.4 meters high. So you kind of have to make a triangle out of that somehow, some way. That's all that last section is, just kind of word problems. But the trig you guys know how to do. So I'm going to get a timer up for, what is 20 to 10 right now. We'll put a timer up for 15 minutes, and we will let you guys work. Maybe just skim through some of the problems, check your answers as you're going. And if you run into problems with anything, come back and I will help you through them. And then we're going to actually have science at 10:05. But if you have any problems, we'll go through them on Monday morning at 9. But then you should just be done all of this Unit 8 stuff. So definitely not a very long unit. So we'll put up a timer for 15 minutes, meet you back here in 15, and if you have any questions, we can go through them together. If not, you should hopefully finish off that learning guide by Monday. Thanks. All right, guys, welcome back. Did anyone run into any issues with any of those questions that we were left with there? Anything you want to go through, didn't know how to find it, didn't know which trig function to use? I'd be happy to go through it. Great, Jenna. Good to hear. Anyone else? Anyone want to go through anything? No? Yes? Maybe? All right. So this is kind of the plan for the remainder of Unit 8 here. I'll make you guys a deal. This is good. Jesse's away, he's going to miss this. This is the deal. Leads is back. Good. All right. So we have our learning guide, and basically I need to get my marks in before the middle of next week, essentially. So I need this stuff to be kind of done, and we haven't been on a very good record of getting stuff in as a whole in this group. So I'll give you this option. If you get your learning guide done, this Unit 8 learning guide, minus the questions I crossed off, so you don't have to worry about those. On Monday's class, Monday at 9, we'll spend an hour. I'll go through any questions you had on the learning guide. I'll go through the whole thing with you if you want. If you get this learning guide in Monday at 3 o'clock, then you don't have to write the Unit 8 test. If you get your learning guide in after 3 o'clock on Monday, you got to write the test, the Unit 8 test. Madison, did that answer your question? All right, so 3 o'clock Monday, and of course, Monday morning we're going to spend an hour going through any questions you guys had on this stuff. If you get your learning guide in before 3 o'clock on Monday, all the questions are done, no test. After 3 o'clock, test. Is that fair? I know, Mrs. Wood. No test. If, and only if, the learning guide is in before 3 o'clock on Monday. If not, tough kittens. You gotta do the test. So that's my deal with you. Thank you, Jesse. Glad you came back to got that. Oh, rainbows and butterflies. That's good. All right, we're gonna sign off now. Give you guys about 5 minutes. At 10:05, we'll log in with science and get started on that. So go grab a drink, cookie, coffee, whatever you need to do to stay awake, and we'll jump into science. You don't have to log out of Blackboard if you're new to the program. You don't have to log out of Blackboard. You can just stay in. We'll just reboot everything, and we'll start a new video here in a second. So we'll see you in 5 minutes, guys. Thanks.